All right, what's up, everybody? This is assignment 10.2. So what we are going to be dealing with is another type of kind of measurement of angles, and that is going to be introducing us to these things called radians. So let's go ahead and get busy with that. All right, so again, before I get to the problems, here is the general gist of what this is. Okay, here is a circle. All right, most of us are pretty familiar with degrees. So 0 degrees is literally 0 degrees. 90 degrees is perfectly an L-looking shape. 180 degrees, right? 270 degrees. And then 360 degrees is the same thing as saying 0 degrees. You just go around in a complete circle. All right, so that is degrees. And so other really kind of important angles are 30 degrees, 45 degrees, 60 degrees, et cetera, et cetera, et cetera. All right, so you can kind of go around the circle as such, and you can figure out these angles pretty easily. Okay, now, let me introduce you to a thing called radians. Radians, again, are the exact same concept. It's just a measurement of an angle. So again, 0 is established right here. So 0 radians. Okay, probably the most important one that you probably really have to recognize is what 180 degrees is. 180 degrees is 1 pi radians. 1 pi radians. All right, so 1 pi radians is 180 degrees. So kind of knowing what we know about stuff, if 1 pi is 180 degrees, well, what would be half of that? AKA 90 degrees. All right, well, it'd be a half pi. That's what that is. All right, so 90 degrees and 1/2 pi are the exact same thing. So we are creating kind of like this different category. So half of a half is a fourth. So that would be 1/4 pi, et cetera, et cetera, et cetera. And then these 30-degree angles, these are sixths. So 1/6. This would be technically 2/6, which is AKA 1/3. And then everything kind of goes off of that. So I kind of count by thirds. 1/3, 2/3, 3/3 is 1, 4/3 is down here, 5/3, and 6/3 is 2. Okay, so a complete circle is 2 pi. And then 6, this would be a little bit short than 1, so this is 5/6. And this would be 7/6. All right, and this would be a little bit short of 2, so this is 11/6. And then fourths, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. And then 1/2, 2/2, 3/2. All right, so these are radians. Now, in general, what a radian is and what a degree is kind of like how I kind of not remember them, but kind of how I remember what to do is we're going to be asked a lot of these questions about like, hey, I want you to convert this into radians. They'll say, 210 degrees. What is that in radians? Or something along that nature. And so what I kind of see is this. Radians are generally a really small kind of number. Radians are really generally small. And degrees are generally big. Looking at it, all right? Generally big, small and big, okay? So if they give me a degree and I need to turn it into a radian, okay? And this is kind of what I'm referencing right here. The question really kind of falls is, do I multiply by 180 or do I divide by 180? So if I have a number and I need to make it smaller, I would take my number and I would divide by 180 generally. That's what I would do. Or if I want a small number and turn it into a big number, I would take my number and I would multiply by 180. That's generally what you do to make this conversion. Do you divide by 180 or do you multiply by 180? And then it's kind of up to you just to not mess up. Right? That's kind of how it goes. Radians will have pi's, degrees will not have a pi attached to it, so to speak. All right, so rewrite 40 degrees into radians. So I got 40 degrees. 40 degrees is a big number. It's a degree. So if I'm going to turn this into radians, what I in essence have to do is I have to divide by 180 and slap a pi on it. Okay, so 40 divided by 180 is kind of long story short on this problem. So 40 divided by 180 is kind of, wrong calculator here. So in this situation, this is going to be 40 divided by 180, 2 ninths. That's radians. There you go. So I divide by 180. $135, turn that into radians. So again, I divide by 180. Three-fourths. 216. Okay, now, so that is turning degrees into radians. So in essence, what you do is you divide by 180, because a degree is a big number, and you want to make it smaller. So how do I make 260 smaller? Well, I divide. Okay, you divide to make that happen, right? Well, now we're asked the exact same question, but in reverse. They give us this radian, and we need to figure this out. What the heck is the degrees? So this is a small number. That's a small number. That's radians. So how do I turn that into degrees, a big number? Well, I have to multiply, of course, silly. And that's what you have to do. So currently, we have 16 pi over 5. That's right now what we have. So I need to multiply by 180, technically 180 over pi. All right, so the pi's are going to cancel each other out. And I'm left with 16 times 180 divided by 5. 576 degrees. Multiply by 180. All right, so right now we have negative 5 pi over 6. So into degrees, what we're going to have to do is going to have to multiply by 180. So again, the pi's are going to cancel out. So negative 5 times 180 divided by 6, negative 150. Tough stuff. Yep. All right. Okay. Now what we are asked to do now is kind of identify what potentially could be your angle. Okay, in quote unquote standard position. Okay, standard position just means our angle is somewhere in between 0 and 360 degrees. That's what it means to be in quote unquote standard position. So it's somewhere in the world of reality. All right, so here they give us 500 degrees. All right, so what 500 degrees is it's more than one circle. All right, so it's going to be, somewhere more than one circle. So to put this in standard position, what you do is you take the measurement that you have, and what you do is you subtract circles off of it, and as many times as you need to. So 500 minus one circle says that this is technically 140 degrees. So 140 degrees. So think about what that means, is this. This is 0 degrees, this is 90 degrees, and this is 180 degrees, 270, et cetera, et cetera. All right? 140 degrees is bigger than 90, but yet smaller than 180. So this would be technically, something like that would be 140 degrees. So find the picture that looks something like that. Okay? My advice would be to convert this into degrees right here. So 7 pi over 12, I'm going to multiply by 180. So this is 105 degrees. And then I would do the exact same process. Where the heck would 105 degrees fall? All right, so if this is 0, 90, 180, all right, 105 degrees is pretty close to the 90 degree mark, a lot closer to 90 than it is 180. So it'd be just a little bit bigger than 90 degrees. So 15 over 4. Subtract a circle. Okay, so this turned into 675 degrees. So I took a circle off that to make it more realistic, and so that's 315 degrees. Okay, so that's 315 degrees. So I need to identify where the deuce 315 degrees is. So again, 0, 90, 180, 270, 360. All right, so 315 is bigger than 270, all right? So it's bigger than 270, and it's kind of in between, so it's down there somewhere. And the only one that looks anywhere close would be. Okay, last but not least, 7 over 15, so 7 over 15. Okay, I'm going to multiply by 180. Okay, so this is the same thing as saying 84 degrees. This is 0, 90. It's a little bit smaller than 90, but pretty close. So just a little bit shy of the 90. So this is the angle that would be